We've got next weekend's Grand Prix on our mind as we roll into the upcoming weekend, so we're very excited about that. And we have Angela Cavanaugh from the Michigan Science Center here to talk about how we can get these cars going, sort of a demonstration to get us in the mood for the big Grand Prix, but it's also with science that can help teach kids. So what are we learning today?
Absolutely. So at the Michigan Science Center, we're really excited about the Grand Prix, so we're going to have some car-based activities that we're doing this weekend and next weekend to help people get really excited and learn a little bit more about how cars and motion and things like that work.
Well, I see all of this. It reminds me of my kids, my childhood, rather. You can see the Hot Wheels and all of that. So how are we going to make it work?
All right. So the challenge here is actually part of a new exhibit that we've recently refreshed called Play Lab. And in Play Lab, we're working on tinkering, and we're working on thinking about how things work and interact with each other. And so our challenge here today, as you can see, we have 2 sets of flat tracks, and then we also have this very complicated circular track over here. So the challenge is to see, can we make the car go forward without touching it with our hands, right? If you push that little yellow car down the track, easy to make it move.
There you go.
But I think we can use a little bit more science and a little bit more fun to do that.
Let's do it.
So our first way that we have here is to use some potential energy. So we've created sort of an upward bend in our track, and if we put the car there, we can see potential energy turns into kinetic energy. Our race car goes down the track. But I think we can do something else that's kind of fun. If we use this flat track without using potential energy this time, let's see if we can use a balloon and transfer the energy from the pressure inside of the balloon, I'm going to let you blow that up, to the motion of the car. So obviously the Indy cars that are used in the Grand Prix won't have motion that comes from things like this. They use combustion engines, but we're going to see if this balloon will work. Let's see. Go,
Let's
car.
hope it works. A little bit. A little bit.
So our design needs a little bit of work, but that's okay because you can come to the Science Center and try out some different designs.
Maybe more air in the balloon.
Maybe more air. Maybe we connect it to the car. There's a world of possibilities that we can try with this tinkering.
Well, this looks like a lot of fun. I want to play with this. I was doing it earlier.
So this sort of is the bigger challenge. So once we can get our cars to move on the flat tracks, the challenge is, can we create enough energy, enough acceleration that the car can actually go through this winding track here? Now, this is the piece that came with this race car track. And all this does is when you hit this, it transfers a little bit of energy to a little sort of paddle that shoves the car along.
I'm going to do it harder.
There you go. And now if you hit it hard enough, obviously it will go all the way through. But give it a really light tap this time. Oh, it didn't quite make it, right? And so in order, especially as the car goes upside down, we have to create enough force that the car is constantly pushing on this rather than gravity pulling it down, which is how it'll keep going. So that's why we have to hit it hard enough. Hit it one more time just for fun.
Really hard?
Really hard.
And that worked. That worked. So when we hit it lightly, it just stops right here. And of course, as you said, gravity took control.
It's called the centripetal force is what holds that up there. They're very sciencey. But something else really cool that's happening is that at the Grand Prix, there's an event called the Grand Premiere. And that is basically a big fancy dinner and fundraiser. And the Grand Premiere, the sponsors have chosen our STEManista project as one of their main causes this year.
Okay, so what are you guys doing for that? Tell me about that program.
So the STEManista project is for girls who are in grades 4 through 8 to really continue their engagement and interest in science, because that is when we see a lot of that age group sort of start to lose interest in science.
Social media, all those other things.
Exactly. And so we have programs that we do on site. The next one is in July, and it's free for that particular demographic. Once again, those 4th through 8th grade girls. And what we do is we bring in community partners. We had one a couple months ago that was great. Growtown and Detroit Hives were there. We talked a lot about rewilding and bringing nature back to our cities. This is an example of one of the projects that came from that. One of our participants sort of reimagined how we can bring more wildlife into our areas. And so this project is really designed to help those girls continue their interest, so hopefully they'll pursue science and STEM in high school and college and in their careers.
Well, how do we find you if we don't know where you are? Tell us.
So Michigan Science Center is 5020 John R. right in Midtown. And you can also find us at our website or on our social media. That's where we post all of the information about our STEManista project.
Thank you so much, Angela Cavanaugh from the Michigan Science Center. We love it when you guys come out, and we had so much fun today talking about the Grand Prix.
Yes.